Good morning. So today we are going to see about how the WEP works. So the client and the access point have a pre-shared key. The access point sends a random number to the client, which the client then encrypts using the key and returns to the access point. The access point decrypts a number using the key and checks that it is the same number to authenticate the client. Once the client is authenticated, the access point and the client communicate using message encrypted with the keys. Weak encryption key. WEP allows to be either 64-bit or 128-bit, but 24 of these bits are reserved for initialization vector, thus reducing effective key size to 40 or 140 bits. Keys were either alphanumeric or hexaphrases that user typed in and were therefore vulnerable to dictionary attack. Static key. Since a key was just a value the user typed in at the client and AP, and since users rarely change this key, one key would be used for many months of communication. Weak encryption process. A 40-bit key can be brute force easily. Flaws that were eventually discovered in the RC4 encryption algorithm WEP users made the 104-bit keys easy to crack as well. Hence, to summarize, the wired equivalent policy is an obsolete, severely flawed security algorithm for 802.11 wireless network introduced as a part of original IEEE 802.11 standard, rectified in 1997. Its intention was to provide data confidentiality comparable to that of traditional wired network. WEP recognizable by its key of 10 or 26 hexadecimal digit was at one time widely used and was often the first security choice presented to user by router configuration tool. Subsequent to 2001 disclosure of a severe design flaw in the algorithm, WP was never again secure in practice. In the vast majority of cases, Wi-Fi hardware devices relying on WEP security could not be upgraded to secure operation. Some of the design flaws were addressed in WEP2, but WEP2 also proved insecure and another generation of hardware could not be upgraded to secure operation. In 2003, the Wi-Fi Alliance announced that WEP and WEP2 has been superseded by Wi-Fi Protection Access WPA. In 2004, within the ratification of the full 802.11i standard, that is WPA2, the IEEE declared both WEP40 and WEP104 have been depreciated. WPA retained some design characteristics of WEP that remain problematic. WEP was only encryption protocol available to 802.11a and 802.11b devices built before the WPA standard, which was available for 802.11g devices. Hence, some 802.11b devices were later provided with firmware or software updates to enable WPA, and newer devices had been built in. So in our next section, we will be discussing in detail about WPA, which is Wi-Fi Protected Access. So the Wi-Fi Alliance has completely done away with the WEP 40 and WEP 104, and now what is in use is WPA, which is Wi-Fi Protected Access. Thank you.